Hello everyone, hope all of you are doing well. Today we are going to start with plus 1 physics previous question paper discussion. We will discuss almost 10 years of question paper in chapter wise. Hope it will be helpful for you. Are you ready to go with the first question? Today we can discuss the questions from units and measurements. And we are starting with the year 2016, that is say examination. And this is a 4-mark question. Okay, there is 2 parts for the question and each question carries 2 marks. So we can go to the question. The first question is, length of a sheet is 17.3 plus or minus 0.3 centimeter and breadth is 3.12 plus or minus 0.08 centimeter. Calculate the percentage error in the area. And the second part of the question is, using the principle of homogeneity of equation, check whether the equation is correct. That is, T is equal to 2 pi root of G by L, where T is the time period, G is acceleration due to gravity, and L is the length of the pendulum. So in the first question, we have to calculate the percentage error in the area, where the length and breadth are given. And also in the second question, we have to check the correctness of the equation by using homogeneity principle. Okay, so we can move to the answer. Now we can write down the given quantities. What are the given quantities here? The length and breadth are given, right? So how we can write length? Length is equal to L plus or minus delta L, that is equal to 17.3 plus or minus 0.3 centimeter. So what is L? L is equal to, yes, 17.3 centimeter. And what is delta L? That is 0.3 centimeter, right? So what about the breadth? Breadth is given as 3.12 plus or minus 0.08 centimeter, right? So how we can express the breadth? That is B plus or minus delta B, right? So what is B here? B is, yes, 3.12. And what is delta B? Delta B is 0.08 centimeter. Okay, now suppose we are having length and breadth. So how we can calculate the area? We can find area that is equal to length into breadth. Here L into B we have to find. Yes, here we have to multiply the given quantities, that is length and breadth. So we have already studied that when 2 quantities are multiplied, how we can find the maximum relative error. So that will be the sum of relative errors in the individual quantities. Right. So suppose we are having A, that is the area, as the product, and then we have to multiply with length and breadth. We can write the equation, that is A will be equal to L into B. Right. So what is the relative error in A? That is delta A by A, isn't it? Then what about length? The relative error in length is delta L by L, and relative error in breadth will be delta B by B. So if we are multiplying the 2 quantities, the maximum possible relative error will be the sum of the 2 quantities, right? The sum of the relative errors of the individual quantities. So that we can write down delta A by A is equal to delta L by L plus delta B by B. And here we have delta A by A. And what is the percentage error? Because here we have to calculate the percentage error. So that is relative error into 100, right? So that is delta A by A into 100. So that we can just find delta A from this equation. That will be delta L by L plus delta B by B into A, isn't it? So if you are getting delta A, we can find delta A by A into 100. That will be the percentage error. Now we can substitute for the values, that is delta A is equal to 0.3 by L is 17.3 plus 0.08 divided by 3.12 into area, that is L into B, right? That is 17.3 into 3.12. If we calculate this, we will get the value as 2.32. Now we can find the percentage error, that is delta A by A into 100, right? So here we have delta A as 2.32 and by A is 17.3 into 3.12 again, right? That into 100. Now we have to calculate. So when we calculate, what we will get? The value is, yes, 4.3%. So that is the percentage error in area. Now we can answer the second part of the question. What is the question? By using the principle of homogeneity of equations, we have to check the correctness of the equation. The equation is T is equal to 2 pi into root of G by L. Okay, so that what is homogeneity principle? We have already studied that in any correct equation, the dimensions of all the terms must be identical. So that here we have to prove all terms are having the same dimensions. Okay, so we can find the dimension of each term separately. So our equation is T is equal to 2 pi into root of G by L. So we have a root here. So in order to avoid that, what we can do? Can we multiply here that or take the square? Yes, we can take the square of this. That is T square will be equal to 4 pi square into G by L. Now we can avoid the root. Otherwise also we will get the answer. But if we square the equation, that will be more easy to find. Okay, that is why we are doing that. Everywhere we are taking the square. And then we have T square is equal to 4 pi square into G by L. Now we can find the dimension of each term. What is the dimension of T square? That is the time period, right? So time itself. T square is equal to T square itself. Then what about G? G is the acceleration due to gravity. That will be velocity by time. That is L T raised to minus 1 by T. That is equal to L T raised to minus 2. And what about L? L is the length, so that the dimension is L. Okay. Now we can find G by L because 4 pi square is a constant. Is there any dimension for 4 pi square? No, because that is a constant. So constant is not having any dimension. Now we can find G by L. The dimension of G is L T raised to minus 2 by L. Right. So what we will get? G by L is equal to that L and L will get cancelled. Then the answer is T raised to minus 2. Okay. And what about the LHS? LHS is T square only, right? So how we are getting LHS is T square and RHS is T raised to minus 2. So what we can conclude here? Here LHS is not equal to RHS. So that the equation is dimensionally wrong. Okay, hope it is clear to you. Now we can move to the next question. The question is from the year March 2017. This is also a 4-mark question. Here we have 2 parts. That is, the first question is, figure below shows the parallax method to measure the distance d of a planet S from the Earth. And a figure is given here. Here we can see the parallax angle we have to find, and the distance between 2 points on Earth, that is the baseline is marked as B, and we can see the distance D, that is between Earth and the planet. Okay, and mark the parallax angle theta in the figure and explain how the distance D can be measured. So this is the first question. And the second part is, check whether the equation mv square is equal to mgh is dimensionally correct. So these 2 questions are there. Here we are having 2 marks for each questions. Okay. Here in the first part of the question, we have to find the parallax angle and also the distance we have to calculate, or the method we have to explain. And the second part is to check the correctness of the equation by using homogeneity principle. Now we can answer the question. how we can measure the large distances such as the distance of the planet or star from Earth? Can we use direct methods? No. So we have already studied that the parallax method can be used to measure large distances, right? So that the distance of the planet from Earth is taken as d, and the distance between 2 points of observations is called base, that is represented as b. Okay. Also the angle between two directions of observation at the 2 points is called parallax angle theta. Here, for applying the parallax method, we have to observe the planet simultaneously from the two observations, that is A and B on Earth. Okay, then we can measure the parallax angle theta. Here the theta is marked, that is the parallax angle. Here we can see that d is the distance between the Earth and the planet, that is very large distance, and b is the distance between the two observatories, that is A and B, that is on the Earth. Okay, so we can see that d is very large compared to b, right? So that we can take this AB, that is B, as an arc of length. Okay, so that arc will be having a length b on a circle with a center at S. Okay, we can imagine a circle with the center at S and the d as the radius. Okay. Now here we have the parallax angle theta, the arc length as b, and the radius is capital D, right? So can we connect these three? So how we can find the angle? We have studied that angle is equal to arc by radius. Then what will come? That theta is angle is equal to theta, that is theta is equal to arc is b by radius is d. So that will be theta is equal to b by d, right? Then how we can find d? That is the distance between the Earth and the planet that we want to calculate, right? So how we can find? Yes, we can cross multiply here, right? So what we will get? D into theta is equal to b. So that d is equal to b by theta. So that is the equation for finding the distance between Earth and planet. Okay, thus by measuring b and theta, the distance to the planet can be determined. Okay. Now we can answer the second part of the question. Here we have to check the correctness of the equation by using dimensions. So which principle can be used here? Yes, we can use homogeneity principle, right? So we can find the dimension of each term separately. So first of all, mv square and then mgh, the dimensions we have to find. So we can check the dimensions one by one. What is the dimension of m? That is mass, so that will be m. Okay, then what is the dimension of h? That is a length, right? So that is L. Then what about v, velocity? That is Lt raised to minus 1, that is displacement by time. So that will be L by T, that is Lt raised to minus 1. Then what about g? G is the acceleration due to gravity. So that will be velocity by time. So that is Lt raised to minus 1 by T, that is equal to Lt raised to minus 2. Now can we substitute the dimensions in mv square? So what we will get? We have the dimension of m as m and v as Lt raised to minus 1. So whole square we have to find, right? So what will be the dimension of mv square? We will get m L square t raised to minus 2, right? And what about mgh? M, the dimension of m is m, then g is Lt raised to minus 2 and h is L. Okay, so that will be again m L square t raised to minus 2. So what we can understand from this LHS and RHS? Here we have the same dimensions in LHS and RHS. That means the equation is dimensionally correct. Now we have proved that this is dimensionally correct, right? But is this the exact equation? mv square is equal to mgh? No, the actual equation is actually half mv square is equal to mgh, right? Now what we can understand from this, a dimensionally correct equation need not be an exact equation, right? So this is a drawback of dimensional analysis. Is it clear? Okay, now we can conclude the video here. If you like my video, please like, share and subscribe. Thanks for watching.